Welcome to today's Explainer, where we're unpacking a massive, kind of counterintuitive reality in software engineering. You know the standard clean code dogma, right? The mandate that tells us smaller is absolutely always better? Well, what if that's actually destroying your productivity? We're constantly told to keep methods under 10 lines, classes under 100, and break every single monolith into microservices. But today, we're zooming in on one core concept that challenges pretty much everything we think we know about organizing our code.
Imagine this frustration. You sit down, right? You just want to understand how a simple user login button works. But instead of reading one clear block of logic, you find yourself tracing through a login button handler, which calls a login presenter, which talks to a login service interface, which points to a login service implementation class, which delegates to a login repository, which finally hits a database helper. It's madness. You have to open 6 different files just to follow a single straight-line execution path. We've all been there, clicking through tabs in our IDE, literally losing our train of thought. So that brings us to a really massive question. Why does breaking down code sometimes make it so much harder to understand? We're always told that modularization makes things simpler, cleaner, and easier to digest. So when we get completely lost in that maze of 6 files, we usually just blame ourselves, don't we? We think, oh, I just don't understand the architecture, or I need to hold more in my working memory. But what if the problem isn't you? What if the problem is the architectural dogma itself?
Well, the answer actually lies in a deceptively simple but profoundly important core concept, the more is more complex, or MMIC principle. Basically, in software engineering, adding more entities inherently increases the total complexity of the system. We're talking about anything here: new lines of code, private helper methods, classes, packages, microservices, or even just database instances. Every single new entity you create, it adds an invisible layer of friction. To really picture how this friction manifests, think about a storage organizer for your tools. If you throw 1,000 tools into a single, massive, unsorted box, you get complete chaos, right? That's under-modularization. Finding one specific screwdriver in that pile is an absolute nightmare. But look at the flip side. Imagine storing each of those 1,000 tools in its own tiny, individual, locked box, each with its own lid, a label, a latch, and a dedicated shelf. That's over-modularization. Sure, they are perfectly sorted, but the overhead of finding the right box, unlocking it, taking out the tool, locking it back up, and putting it on the shelf, it's total exhaustion. And in the real world, this underlying friction creates what the source material accurately calls architectural nightmares, which show up at literally every level of our design. First, you've got microservices inflation, where teams will take a simple low-traffic web app and fracture it into like 15 microservices. Suddenly, you're dealing with distributed transactions, eventual consistency, API gateways. The interaction complexity absolutely dwarfs the actual business logic. Then you have interface per class over-engineering, literally doubling your file count for zero reason, or documentation bloat, where maintaining 100-page wikis becomes a full-time job. And finally, micro-method hell, where a simple sequential algorithm is shattered into so many single-use private helper methods that you're just constantly jumping around the file to read the story of the code. To really drive this home, there's a specific, painful anecdote from the source material that's honestly hard to believe until you've lived it. An engineer took over a codebase where an Android screen's presentation logic was split into 8 separate micromodules, each containing just 1 or 2 small classes. Think about that tiny boxes analogy again. Because of this setup, a simple, trivial bug fix in the UI flow required editing 6 build scripts, 8 classes, and sitting through a multi-minute compilation step. The architecture was actively punishing the developer for just trying to do their job. But here is the incredible part. That same engineer took those 8 micromodules and simply merged them back together into a single module. The result? Compile times plummeted by 40%. 40! And even better, developer velocity absolutely tripled. Just by removing those artificial boundaries, the code became easier to read, easier to write, and incredibly faster to build. Now, to understand why merging those modules works so well, we have to look under the hood at the underlying science. Every architectural decision is basically a tug of war between 2 forces. When you look at intramodule complexity, which is the internal logic within a specific module, breaking things down makes this internal complexity go down. Makes sense. But you have to balance that against intermodule complexity, the heavy overhead of the connections between those modules, wiring components together, passing data across boundaries, maintaining APIs. As you create more modules, this intermodule complexity just skyrockets. So, the absolutely crucial point here is finding the balance, which is known as the Goldilocks conjecture. Research shows that software defect density actually forms a U-curve. If you have very small modules, defects are extremely high because of that interaction overhead. The communication between tiny pieces just gets mangled. But if you have very large modules, defects are also high because the internal logic is just too dense and chaotic. To maintain true code quality, we as developers must deliberately target the Goldilocks zone, right at the bottom of that U-curve, where both internal density and communication overhead are minimized.
Okay, so how do we actually do that? How do we reclaim our codebase sanity? Well, we can boil it down to 4 actionable rules. Step 1, you must consciously target that Goldilocks zone. Step 2, change your default behavior. Write code inline by default, just in a linear fashion, and only extract helper methods or classes on demand when you genuinely need to reuse them. Step 3, relentlessly eliminate redundant abstractions. And step 4, minimize your documentation. Only document the hard stuff, the why, the edge cases, the weird design decisions, not the obvious getters and setters. And targeting that Goldilocks zone isn't just a theory. It comes down to continuous monitoring and concrete metrics. A really great rule of thumb highlighted in the source is keeping source files between 100 to 400 lines of code. If you see a file dipping below 30 lines, you should seriously consider merging it with related logic. Really, don't be afraid to consolidate. On the flip side, if it balloons above 600 lines, well, that's your signal to evaluate a split. It's about practical sizing, not dogmatic rules. And speaking of eliminating redundant abstractions, if you only take away one coding habit from this explainer today, please let it be this. Remove interface implementation pairs where only one implementation exists. In so many enterprise projects, you'll see a user service interface and a user service implementation class, even though there's zero polymorphic behavior needed. It is pure bloat, it causes extra go-to implementation fatigue in your IDE, and it means every new method requires modifying 2 files instead of 1. If there's only one implementation, just use a concrete class. Simple as that. As we wrap up this explainer, it all comes back to a crucial realization. Modularization is an absolutely essential tool. We need it to align our code structure with our domain concepts. But the more is more complex principle acts as a crucial, necessary constraint. Every single new module, class, and line of code you add, it's a liability. It's something that you and your team must now read, compile, test, and maintain forever. Stop creating new concepts and classes once you've accurately modeled your problem. So before you extract that next private helper method or spin up that new microservice or write an interface for a class with only one implementation, take a pause and ask yourself this. Are you organizing your code to solve an actual problem, or are you just building more tiny locked boxes? Keep things balanced, keep things practical, and stay in that Goldilocks zone. Thanks for learning with me today.